Welcome back to the channel. In this video, I am going to explain the Laravel project structure in a deeply detailed, beginner-friendly way, following the same flow shown in the diagram. By the end of this explanation, you'll clearly understand how routes, controllers, models, views, and all the key folders of Laravel work together to handle every request your application receives. Every Laravel application begins when a browser sends a request. This request eventually reaches Laravel's internal engine, which processes it through a well-organized structure. Think of this flow as the blueprint of a house. When you understand how each part connects, everything becomes easier to build. The journey starts inside the Bootstrap folder. This folder is responsible for initializing the entire framework. It prepares Laravel internal files, loads environment settings, registers classes for autoloading, and sets up the foundation your application needs before it can respond to any request. It works like the engine startup that gets your whole app ready. Once Laravel boots up, it loads centralized settings from the config directory. This folder contains configuration files that define how different parts of your application should behave. Inside it, you'll find database configuration, cache settings, session behavior, authentication settings, queue connections, mail drivers, and many more options. These files allow you to control every important behavior of your app in one central place. Laravel reads these settings early in the request cycle to understand how your system should operate. The next major part of the flow is the routes directory. This is where you define what happens when a user visits a specific URL. Inside this folder, there are files like web.php for web pages and api.php for API endpoints. When a user enters a URL in the browser, Laravel checks these route files to determine which controller or closure should handle the request. This is the official entry point where all external requests are mapped to the correct logic. After a route is matched, the request is forwarded to the app directory, which is the core of the entire application. Laravel uses the MVC architecture, meaning model, view, and controller. Inside the app/http/controllers folder, you write controller classes that handle incoming requests. Controllers contain the logic needed to process data, interact with the database, or return views. The app/models folder contains model classes that represent database tables. Models provide an elegant way to interact with the database without writing raw SQL, allowing you to perform queries using clean, object-oriented syntax. The app folder acts like the brain of the application, making the decisions and running the logic that powers the entire system. Anything related to the database is managed inside the database directory. This folder includes migrations, which define the structure of your database tables, seeders, which insert sample data, and factories, which generate fake data for testing. When you run commands like migrate or seed, Laravel uses this directory to build or modify your database structure. For the user interface, Laravel uses the resources/views directory. This is where all the Blade template files are stored. Blade is Laravel's powerful templating engine that allows you to write dynamic HTML in a clean and simple way. You can display variables, loop through data, use layouts, and include reusable components. Everything that the user sees on their screen comes from this folder. Finally, we reach the public directory, which is the only folder exposed directly to the browser. When a user opens your website, the very first file that runs is public/index.php. This file acts as the gateway between the user and the Laravel framework. The public folder also stores CSS files, JavaScript files, images, fonts, and other front-end assets that the browser needs. Anything placed inside this folder is publicly accessible. When you connect all of these pieces, the full Laravel request flow becomes very clear. A user sends a request from their browser. The request reaches the public index file. Laravel initializes using the Bootstrap folder. It loads configuration settings from the config folder. It checks the route definition to decide which controller should handle the request. The controller communicates with models if database interaction is required. The controller returns a Blade view from the resources folder. Finally, the response is delivered back to the user's browser. This is the complete journey of a Laravel request, flowing smoothly through the project structure shown in the diagram. Understanding this flow is the foundation for mastering Laravel. Once you fully understand how these folders work together, building even advanced applications becomes much simpler and more efficient. In this continuation of understanding the Laravel project structure, let's look at how the entire project root is organized and what each folder inside it represents. When you open a Laravel project, the very top-level directory is the project root, which contains every subfolder and file that makes your application run. Inside this root, the main project folder, usually named something like Laravel-project, is where all the core components of the framework live. The structure is designed to separate logic, configuration, assets, and dependencies in a clean and predictable way, allowing developers to easily navigate and manage even large projects. One of the first and most important folders inside the project root is the app folder. This is where the core application code is stored. It contains your controllers, models, and other custom classes. Anything related to your main application logic is placed here. From there, Laravel reads configuration settings stored in the config folder. These configuration files control how your app connects to databases, mails, queues, sessions, and many other services. They form the central control system of your entire project. After configuration, the public folder acts as the main entry point of the application. This is the only directory directly accessible through the browser. It contains the index.php file, which launches the framework and also stores public assets like CSS, images, and JavaScript files. Next to these folders, the Bootstrap folder plays a major role in starting the framework. It loads important classes and optimizes performance when your application boots up. The database folder manages migrations, seeds, and factories, helping you structure and populate your database with ease. The resources folder contains blade templates, raw CSS and JavaScript files, and language files used for localization. This is where you manage everything that eventually becomes the user interface or static resources for your app. On another side of the structure, the routes folder defines all URL routes that your application responds to. Files like web.php and api.php live here, mapping web pages and API endpoints to specific controllers. The storage folder is where Laravel keeps logs, cached data, compiled views, and uploaded files. This folder grows as your application runs. The test directory contains automated tests, allowing you to create unit tests and feature tests to ensure your application works as expected. The vendor folder is created and managed by Composer and stores all third-party packages and dependencies installed for your project. Outside the folders, the project root also contains some essential configuration files. One of them is the .env file, which holds environment-specific settings like database credentials, mail drivers, API keys, and other sensitive information. This file changes depending on where your application is running, local, staging, or production. Another important file is composer.json, which defines project dependencies, version constraints, auto-loading rules, and metadata. Composer uses this file to install and manage all external libraries your application needs. In this part of the Laravel project structure, we focus on the app folder, which is truly the heart of your entire application. This folder contains the most important logic, including your models, your controllers, and many of the classes that define how your application behaves. On the left side of the diagram, you can see the Models section. Models represent database tables, and each model corresponds to a table inside your database. For example, if you have a users table with columns like ID, name, email, and created at, then Laravel will typically have a user model that interacts with this table. The same goes for other tables like posts or products. Models handle CRUD operations, meaning they can create new data, read existing records, update information, and delete entries. All database interactions and business logic related to specific data entities flow through these models. You can easily create new models using simple artisan commands, such as php artisan make model post, which automatically generates a new model file for you. On the right side, the diagram highlights the controllers stored inside the app HTTP controllers directory. Controllers act as the traffic directors of your application. When a route receives a request, the controller decides what to do with that request. It may fetch data from a model, process user input, apply business logic, and finally return a response. Most of the time, that response is a view, a blade template that will be rendered as an HTML page for the user. For example, a user controller may handle user-related actions like showing a profile page or updating a user's information. A post controller may manage blog posts, fetching them from the database using the post model and passing that data to a view for display.
At the bottom right, the diagram connects the controllers to the views stored inside the Resources Views folder. Views are responsible for presenting information to the user. They receive data from the controller and display it using dynamic blade templates. This creates a clean separation between logic and presentation. Controllers never worry about what HTML looks like, and views never worry about database queries. Each layer has its own responsibility, which keeps your code organized, clean, and easy to maintain.
In this section, we dive deeper into the app/http directory, which is the core of how Laravel handles incoming requests. When a user interacts with your website or API, the request enters Laravel and is directed toward the HTTP folder, because this is the part of the application responsible for managing HTTP-based interactions. Inside this directory, the most important area is the controllers folder. This is where you create controller classes like home controller or post controller. These controllers act like traffic managers. They receive the incoming request, decide what needs to happen, and handle the logic that prepares the right response. Whether the user is trying to view a page, submit a form, fetch data, or perform an action, the controller is the first point of logical decision-making. Once a request reaches a controller, the controller can perform several types of operations. It can call models to retrieve data from the database, apply validation to user input, execute business logic, or prepare data to be displayed. After processing everything, the controller decides how to respond. If the request is for a web page, the controller returns an HTML view, usually a blade template stored in the Resources/Views folder. If the request is meant for an API or JavaScript frontend, the controller can return a JSON response instead. Both HTML and JSON responses are handled cleanly and efficiently, making Laravel flexible for building full websites, admin dashboards, or RESTful APIs. The diagram also highlights artisan commands, which are a fast way to create new controllers directly from the command line. For example, running php artisan make controller post controller instantly generates a new controller file with the appropriate structure. This saves time and keeps your folder organized as your application grows. Altogether, the app/http directory is essential because it holds the logic that connects routes, controllers, models, and views into a smooth, functional flow. When you understand how controllers receive requests, process logic, and return responses, you gain full control over how your Laravel application behaves. In this part of the Laravel structure, we explore middleware inside the app/http directory, which acts as a protective layer that every incoming request passes through before reaching the main controller logic. Middleware works like a series of filters or checkpoints placed between the request and the controller. When a request enters your application, Laravel routes it into the middleware layer, where different small checks are performed. For example, the authenticate middleware checks whether the user is logged in. If the user is authenticated, the request is allowed to continue. If not, the middleware can stop the process immediately and return a response like a 401 unauthorized error. Another common middleware is Verify CSRF token, which ensures that forms submitted from the browser include a valid CSRF token, protecting your application from cross-site request forgery attacks. These checks are simple but extremely important because they protect your application from unauthorized access or malicious activity. All middleware is registered and managed by the kernel.php file inside the same directory. The kernel organizes middleware into two main categories: global middleware, which runs on every request, and route middleware, which only runs on specific routes when needed. Once the middleware is registered in the kernel, incoming requests automatically flow through the defined filters. The middleware layer has the ability to modify the request, check conditions, or even block the request entirely if something is not valid. If each middleware check passes, the request finally reaches the controller where your main application logic lives. The controller processes the request, interacts with models, performs necessary operations, and prepares the appropriate response. Once the controller finishes its work, the response travels back through the middleware layer again and then is finally returned to the user's browser. This entire cycle allows Laravel to enforce security, validate behavior, and maintain a clean request lifecycle. Middleware gives you precise control over what is allowed into your application and what is not.
From login protection to input validation, middleware acts as the silent guardian that makes sure every request is safe and properly filtered before reaching your core logic.
In this part of the Laravel project structure, we look at the app/console directory, which is responsible for handling artisan commands and scheduled tasks inside your application. While most of the Laravel application focuses on handling web requests, the console directory focuses on actions that are executed from the command line. Whenever you run commands like php artisan migrate, php artisan serve, or php artisan schedule run, Laravel processes these instructions through the console environment. Inside the app/console folder, you'll find two main areas, the kernel file and the commands folder. The console kernel works as the central hub that registers custom commands and manages scheduled tasks. This is where you define repeated operations such as daily cleanup jobs, automated reports, or cron-like schedules that Laravel should run automatically. The kernel makes sure your custom commands are recognized by the artisan tool so you can execute them whenever needed. Inside the commands folder, Laravel stores all the custom artisan commands you create. Each command is represented by its own PHP file, such as customcommand.php or mytaskcommand.php. These files contain the logic of what the command should do when executed. For example, if you want a command to generate a daily report, send emails, clean temporary files, or fetch data from an external API, you can program all of that inside a custom command file. Creating a new command is easy using Artisan. By typing a command like php artisan make command generate report -- command equals report.generate, Laravel instantly generates a new command file for you. After that, you simply open the file, write the logic you want to automate, and register it in the console kernel so Artisan knows it exists. The diagram shows how these commands fit into the application structure. Once created, a console command becomes a powerful tool that can interact with every part of your Laravel application, from database operations, sending emails and managing files, to communicating with external APIs. All of this happens behind the scenes without needing a web request. Developers can run these tasks manually from the terminal or schedule them to run automatically using Laravel's built-in scheduling system. Commands like php artisan list, php artisan schedule run, or php artisan report.generate are examples of how these console commands are executed. This system gives Laravel developers the ability to automate repetitive work, streamline maintenance tasks, and keep their applications running smoothly without constant manual intervention. In this part of the Laravel project structure, we explore the app providers directory, which plays a major role in bootstrapping the entire application. When a request enters a Laravel project, the framework doesn't immediately execute controllers or routes. Instead, it first prepares the internal environment through a series of service providers, all located inside this providers folder. These providers act like the application's setup managers. They register important components, configure internal services, and ensure everything is ready before the app begins handling actual user requests. The app service provider is one of the most central providers. It handles global bootstrapping asks such as binding interfaces to implementations, sharing data across views, and registering custom logic that should run when the application starts. Another important provider is the auth service provider, which handles authorization rules, policies, gates, and everything related to how users are allowed to interact with the system. It ensures that different parts of your application are protected and only accessible to the right people. The route service provider is responsible for loading and mapping your routes. It determines how your web routes, API routes, and custom route files are registered and connected to the rest of the framework. All of these service providers work together to prepare the application to a fully ready state. Once a request comes in, the kernel triggers these providers and follows a specific bootstrapping flow. First, Laravel registers bindings, meaning interfaces and contracts are matched with their actual implementations. Then it registers any event listeners, which allows your application to respond to important internal events such as user login, database changes, or other custom triggers. Next, the providers register the application routes so the system knows which URL should lead to which controller. The authentication layer is also configured at this stage, enabling guards, user providers, and access control logic.
After all of these steps are complete, the application reaches a fully bootstrapped state. Only then is Laravel ready to process incoming requests, route them to controllers, and return responses. This bootstrapping system is what gives Laravel its power, flexibility, and clean organization. By understanding your service providers, you gain deeper control over your entire application's behavior.
In this part of the Laravel structure, we're looking at the core of the entire framework, the app folder, which is the true home of your application's main logic. Everything that defines how your Laravel project behaves, how it talks to the database, how it handles user requests, and how it automates background tasks lives inside this folder. On one side, we have models, which contain all of your data logic and database interactions. Models are responsible for representing tables, retrieving information, creating new records, updating data, and applying business rules. On the other side, we have controllers, which act as the central coordinators for user requests. Whenever someone accesses a page or calls an API endpoint, the controller decides what data to gather and which response to return. Beneath that, middleware plays an important security role by filtering each incoming request before it reaches the controller. Middleware checks things like authentication, permissions, tokens, and other conditions to ensure only valid requests move forward. Also inside the app folder are your service providers, which are responsible for setting up and registering the services that power your application behind the scenes. These providers help bootstrap your project, configure features, and wire up different parts of the system so everything runs smoothly. Finally, the console commands live here too, giving you the ability to create custom tools for the artisan command line. These commands can automate tasks, interact with the database, manage files, send notifications, or do anything your application needs. Altogether, the app folder is the beating heart of your Laravel project, connecting models, controllers, middleware, service providers, and console commands into one unified and powerful system. Whenever you build new functionality, almost everything you create will live here, making this folder the core foundation of your entire application.
In this section of the Laravel structure, we're looking at the Bootstrap folder, which acts as the internal launchpad of the entire framework. Before Laravel can process any request, it has to prepare itself, load its core components, and assemble everything it needs to run smoothly. That entire preparation phase happens inside the Bootstrap directory. The most important file here is app.php. When a request enters the application, this file is responsible for initializing the framework, loading essential configurations, and preparing every subsystem for incoming traffic. It sets up the service container, registers the service providers, and ensures that Laravel is fully ready to route requests, process logic, and deliver fast, reliable responses to users. Without this initial bootstrapping process, none of Laravel's features would be functional. The Bootstrap folder also contains a cache directory, which plays a huge role in optimizing performance. Inside this folder, Laravel stores compiled versions of routes, configurations, and services. These cached files allow the framework to skip a lot of repetitive processing work. Instead of rereading every configuration file or reparsing all routes every time a request arrives, Laravel simply loads the precompiled cached versions stored in this directory. This can dramatically improve speed, especially in production environments. These cached files are automatically generated by running artisan commands like php artisan config-cache or php-artisan route-cache, which instruct Laravel to compile and store faster versions of these resources. Once the caches are stored, the framework becomes much more efficient, reducing overhead and allowing the application to handle high levels of traffic with ease. Altogether, the Bootstrap folder ensures that Laravel starts quickly, loads efficiently, and performs at its best. It initializes the application through app.php, manages compiled optimizations through the cache directory, and prepares the entire framework so every request can be handled smoothly. By the time Laravel finishes its bootstrapping process, the application is fully ready to route requests, process logic, and deliver fast, reliable responses to users.
In this part of the Laravel project structure, we explore the config folder, which acts as the central control system for how the entire application behaves. Every major feature of Laravel, whether it's handling database connections, sending emails, managing sessions, or storing files, looks to the configuration files inside this directory to decide how it should operate.
These files don't contain application logic. Instead, they define the rules, the settings, and the environment your app should follow. For example, app.php controls core settings like the time zone, locale, and base application name. Database.php defines what database your project should connect to, along with the host, port, username, and driver. Mail.php determines which mail service Laravel should use, what the sender address should be, and what encryption to apply. Queue.php configures the queue system, specifying how background jobs should be processed and what drivers should be used. On the other side, cache.php defines the cache driver and storage location. Session.php sets rules for how user sessions are managed, including lifetime and security properties. And filesystems.php configures the storage disks, whether you're using local storage, cloud storage like Amazon S3, or multiple disks at once. All of these settings are designed to be flexible, meaning you don't hard-code sensitive information directly into these files. Instead, Laravel pulls private values like database passwords, API keys, and mail credentials from the .env environment file, keeping your sensitive data secure and easily changeable depending on whether your application is running locally, on staging, or in production. The config folder simply reads these environment variables and applies them to the framework. This separation gives you complete control over how your application runs without mixing configuration with code. As Laravel starts up, it loads every configuration file in this directory, creating a fully defined environment that your application follows throughout its entire lifecycle. Understanding how these configuration files work gives you the power to customize your application at a deeper level, ensuring everything behaves exactly the way you want.
In this part of the Laravel structure, we focus on the .env file, which acts as the environment-specific brain of your entire application. The .env file is where Laravel stores all sensitive configuration values, things like your database name, username and password, your app name, your app key, whether debugging is turned on, your mail server credentials, and much more. These values are never hard-coded inside the application. Instead, they are read from the .env file so they can easily change depending on where your app is running. One of the most important rules in Laravel development is that you should never commit your .env file to Git or make it public because it contains credentials and private keys that must remain hidden. Laravel provides a .env.example file specifically so you can share the structure of your environment variables without revealing sensitive information. The .env file becomes even more powerful when you consider that different environments use different .env settings. For example, on your local machine, you might enable debugging, use a local database, and turn on features that help you test. In a staging environment, debugging is normally disabled, and the database is connected to a staging server. In production, the settings are even stricter. Debug is always off, a production database is used, and secure configuration values are required to keep your application safe. The same Laravel codebase can behave completely differently simply by swapping the values inside the .env file for each environment. During the boot process, Laravel reads all these .env variables and merges them with the configuration files stored in the config folder. When config/app.php needs to know the app's time zone or environment, it pulls those values from .env. When config/database.php needs the database connection details, it reads them directly from .env as well. The same pattern applies to mail settings, queue connections, cache drivers, and almost every other subsystem in the framework. By the time Laravel finishes loading the .env values and merging them with the configuration files, the application has a fully defined behavior profile. It knows which database to use, how to send emails, what debugging mode is active, and how to connect to every service it depends on. Once all of this is complete, Laravel begins running the application using the exact environment settings you've provided. This makes the .env file one of the most critical parts of the entire project. It gives you flexibility, security, and full control over how your app behaves in development, staging, and production, without ever touching your core code.
In this part of the Laravel structure, we explore the database and migration system, which gives you complete control over how your database schema evolves over time. Inside the database folder, Laravel organizes everything related to database interactions, including factories for generating fake data, seeders for populating tables, and, most importantly, the migrations directory. This migrations folder holds time-stamped migration files that act like version control for your database. Instead of manually creating tables in your database, you define them in migration files, and Laravel automatically builds the schema for you. A typical migration file contains an up method, which describes what the table should look like. For example, creating a users table with fields like ID, name, email, and timestamps, and a down method, which tells Laravel how to reverse those changes if needed. Because each migration file includes a unique timestamp, Laravel always knows the exact order in which to apply database changes, making your schema consistent across every environment, whether it's development, staging, or production. When you run a migration command, such as php artisan make migration create posts table, Laravel generates a new migration file inside the database/migrations directory. You then describe the columns, data types, and relationships inside that file using Laravel's schema builder. For example, defining a posts table might include fields like ID, user ID, title, body, and timestamps, along with foreign keys linking posts back to users. Once your migrations are ready, running php artisan migrate executes them in sequence, creating or modifying tables exactly as defined. This becomes incredibly powerful when working in a team or deploying an application across multiple servers. The migration history ensures everyone's database stays aligned, and new changes can be tracked, rolled forward, or rolled back at any time. With migrations, Laravel turns your database structure into clean, maintainable, version-controlled code, giving you confidence and stability as your application grows and evolves.
In this part of the Laravel database structure, we dive into the database/factories folder, which plays a huge role in speeding up development and testing by generating realistic fake data. Instead of manually creating users, posts, products, or any other records during development, Laravel gives you model factories, blueprints that define what a sample record should look like. Each factory is a simple PHP class that lives inside the database/factories directory. For example, the user factory contains a definition method that returns an array of sample values for each column, such as a randomly generated name, a unique email address, and any other fields the user table requires. Laravel uses the powerful Faker library behind the scenes to create natural-looking dummy data, making your test environment feel much more realistic. Factories can be used in two extremely convenient ways. The first is through Artisan Tinker, where you can open an interactive shell and instantly generate fake records by typing a command like user factory count 5 create. This immediately creates 5 new user records in the database, complete with names, email addresses, and timestamps. The second method is through seeders, allowing you to automatically populate your database with sample records using commands like php artisan db seed class equals user seeder. This is perfect when you want your development environment to always start with a fresh batch of sample data, whether it's users, posts, comments, or any other models. Thanks to factories, you never need to waste time manually inserting test records again. They streamline development, make feature testing easier, and ensure that your database always has realistic data to work with. Whether you're testing authentication, building a dashboard, or experimenting with new features, factories give you an instant, repeatable way to create meaningful sample data that behaves just like real-world records.
In this part of the Laravel database system, we focus on the seeders that live inside the database/seeders folder. Seeders are powerful tools designed to populate your database with initial or dummy data, making development and testing much faster and more convenient. Instead of manually inserting records into your tables, you create simple PHP classes called seeders, such as user seeder or post seeder, which define exactly what data should be added. A typical seeder class includes a run method where you can either generate data using model factories or insert records directly with database queries. For example, a user seeder might create 10 fake users using user.factory.count10.create, or it might insert custom sample users with specific names and email addresses. When the seeder is executed, Laravel runs this code and instantly populates the corresponding table in your database. To run your seeders, Laravel provides the artisan command php artisan db.seed, which triggers the database seeder class. This central seeder can call other seeders inside its run method, allowing you to organize your test data in a clean and modular way. When the command runs, Laravel displays which seeder is being executed and confirms when the seeding completes successfully. This automated approach ensures your development environment always starts with consistent data, whether you're setting up users, posts, categories, products, or any other tables. Seeders are especially useful when working on teams or deploying to different environments because they guarantee that everyone is working with the same starting database state. By combining seeders with factories, Laravel gives you a powerful, repeatable system for filling your database with meaningful test data, eliminating repetitive work and allowing you to focus on building features rather than manually managing tables.
In this part of the Laravel project structure, we take a look at the entire database folder, which acts as the central hub for everything related to your application's database structure, initialization, and test data. Laravel organizes this folder into three major components: migrations, factories, and seeders. And together, they create a powerful workflow for building, shaping, and populating your database. Migrations serve as the blueprint for your database structure. They define how tables should be created, what columns they should contain, and how relationships between tables should be structured. Instead of manually creating tables in a database tool, migrations let you describe these changes in code, making it easy to update, version, and share your database schema across different environments or team members. Every time you run your migrations, Laravel uses these definitions to build or modify the database exactly as intended. Factories extend this workflow by generating fake but realistic test data. Using the Faker library, factories allow you to quickly produce large amounts of sample records for models like users, posts, products, or anything else your application needs from the start. Instead of manually inserting test entries, you simply define a factory that describes what a typical record should look like, and Laravel can instantly generate dozens or even thousands of records on command. This is incredibly helpful during development and testing because it gives you a populated database that feels real without requiring manual setup. Seeders complete the system by inserting initial or default data into your database. While factories are great for generating random test records, seeders are perfect for inserting required or static information, like an admin user, default categories, system settings, or other data your application depends on from the start. A seeder class can also call factories to populate tables with both structured and random data. When you run a seeder, Laravel fills your database with exactly the records you specify, ensuring consistency across all environments: local, staging, and production. Together, migrations, factories, and seeders give you full control over your database lifecycle, allowing you to build the structure, fill it with meaningful data, and maintain it over time with precision, automation, and ease.
In this part of the Laravel project structure, we focus on the public folder, which is the only web-accessible directory in your entire application. When users enter your domain in the browser, every single HTTP request is routed directly to this public folder and nowhere else. This design is intentional because it protects the core of your Laravel project from being exposed to the internet. All important folders like app, config, database, routes, resources, storage, tests, and vendor remain completely inaccessible from the web, keeping your logic, environment variables, and sensitive files secure. Inside the public directory, Laravel stores only the files that the browser should be allowed to load. The most important one is index.php, which acts as the entry point for your entire application. No matter which route a user visits, the request always begins here. Laravel uses this file to boot the framework, load necessary classes, and forward the request into the routing system. Along with index.php, the public folder contains your CSS files, JavaScript files, and public images, essentially anything the browser needs to display your front end. It also includes the favicon and the robots.txt file, which helps search engines understand how they should crawl your site. In a real production environment, when you point your domain to your Laravel application, the server should be configured so that the domain maps directly to the public folder. This ensures the server serves only safe, public-ready assets, while everything else inside your project remains hidden and secure. If the server pointed to the main project root instead, all of your internal files would be exposed, creating huge security risks. That's why proper server configuration through Apache, Nginx, or similar technologies is essential. The server must route all requests straight into public.index.php. From that point forward, Laravel takes over, processes the request, calls controllers, loads views, and returns the appropriate response back to the browser. This setup keeps your application safe, clean, and professionally structured, ensuring a secure boundary between public assets and private application logic.
In this part of the Laravel structure, we explore the resources/views folder, which is responsible for everything the user sees on the screen. This is where Laravel stores all of its Blade templates, special files that blend plain HTML with dynamic data coming from controllers. When a controller fetches information and prepares a response, it sends that data to a Blade view, which then turns it into a fully rendered web page. Inside the Views folder, you might have a welcome Blade file that contains HTML markup combined with small pieces of dynamic content, such as a title variable. Laravel replaces that variable with actual data passed from the controller, allowing the page to update based on real information. You can also create more structured layouts inside the Layouts directory. A layout file, such as app.blade.php, defines the main structure of your site, things like the header, footer, navigation, and container elements. Using Blade directives like @yield and @include, child views can inject their own unique content into the layout, keeping your HTML clean, organized, and easy to maintain. Alongside simple pages and layouts, Laravel's Blade system can also handle dynamic lists of data. For example, a posts/index.blade.php file might loop through a collection of posts using an @foreach directive. Each post's title, excerpt, or other information can be displayed inside the HTML. This turns your views into powerful templates that automatically adjust to the data they receive. The entire process flows smoothly. The controller fetches or prepares the data, the controller returns a view and passes that data into it, the Blade engine processes the template inside the resources/views folder, and the final HTML output is rendered and sent back to the browser. Laravel's Blade system makes it incredibly easy to mix logic-free HTML with dynamic content, providing clean separation between back-end logic and front-end presentation. The result is fast, readable, and reusable templates that make your application's interface flexible and efficient.
In this part of the Laravel structure, we explore the Lang folder, which is responsible for making your application multilingual and ready for a global audience. This folder stores all localization files, simple PHP files that contain arrays of translated text. Each language gets its own dedicated subfolder, such as EN for English or UR for Urdu. And inside each of these folders, you'll typically find files like messages.php. These files contain key value pairs, where the key represents a message identifier and the value is the translated text. Instead of hard-coding sentences directly into your Blade templates or controllers, you refer to them using translation keys. Laravel then automatically picks the correct language version based on the application's active locale. For example, when you write _square messages.welcome in your code, Laravel looks inside the appropriate language folder, finds the messages.php file, and returns the translation for the welcome key. If the app's locale is set to English, it will use the text from lang/en/messages.php. If set to Urdu, it will pull from lang/ur/messages.php. This system makes it incredibly easy to switch languages across your entire site without changing your templates or rewriting your content. Whether you're building a simple bilingual website or a fully international platform, the Lang folder ensures that every piece of text in your application can be translated, organized, and maintained cleanly.
In this part of the Laravel structure, we focus on the resources directory as the main workspace for your front-end assets, everything from JavaScript to CSS and Sass. This folder is where you write and organize all the raw, uncompiled files that shape the visual and interactive parts of your application. Inside resources/JS, you can write modern JavaScript using ES6+ features, modules, reusable components, and whichever front-end libraries your project requires. This is the area where dynamic behavior, event handling, and interactive UI logic begins. Next, in resources/Sass, Laravel gives you a place to create structured modular Sass, or SCSS, style sheets. These files allow you to write cleaner, more maintainable CSS using variables, mix-ins, and nested roles. If you prefer working with plain CSS or need to include styles from third-party libraries, the resources/CSS folder is where those files live.
All of these front-end sources, whether JavaScript, SCSS, or CSS, then pass through build tools like Vite or, in older Laravel setups, Mix. These tools compile, process, bundle, and minify your files into optimized versions suitable for production. Once the build process is complete, the final compiled assets are placed into the public folder where browsers can access them. This workflow keeps your source code neatly organized while ensuring your production assets are fast, efficient, and ready for deployment.
In this part of the Laravel project structure, we explore the routes folder, which is responsible for mapping incoming URLs to the logic that handles them. When a user visits a URL like home or sends an API request such as API/users, Laravel checks the routes files inside the routes directory to decide what should happen next. The most commonly used file is web.php, which defines routes for traditional web pages. These routes support sessions, cookies, CSRF protection, and all the browser-based features you expect in a web application. When a route in web.php is matched, Laravel passes the request to the appropriate controller method, such as home controller at indexed or user controller at show. For API-based applications, Laravel uses api.php, where routes are stateless and optimized for returning JSON responses. These routes typically use the API middleware group and forward incoming requests to API controllers that return structured JSON data. In addition to web and API routes, Laravel includes console.php, which doesn't handle browser requests at all. Instead, it allows you to define custom artisan commands that can be run from the command line. When you register a command here, Laravel knows how to trigger your logic when someone types the corresponding artisan command in the terminal. The final routes file is channels.php, which is used for broadcasting real-time events. This is where you define channels for features like live notifications, chat messages, or any events that needs to be streamed instantly to connected clients. Whenever a request enters the application, Laravel examines these routes files to determine whether the request belongs to a web route, an API route, a console command, or a broadcast channel. Once the route is found, Laravel directs the request to the correct controller method, command, or event handler. This routing system acts like the traffic controller of the entire framework, ensuring every request goes exactly where it needs to go, keeping your application organized, modular, and incredibly flexible.
In this part of the Laravel project structure, we explored the storage directory, which is responsible for holding all runtime data and system-generated files that your application needs while it's running. The storage folder is divided into several important sections, each serving a different purpose behind the scenes. The storage/apt folder contains files that your application creates or stores, such as uploaded images, documents, or any data your app generates during normal operation. When you upload a file through a form, Laravel typically stores it here, unless you configure a different disk. Next is the storage/framework folder, which holds the internal runtime files that Laravel uses to operate efficiently. This includes cache routes, cached configuration, compiled blade templates, session data, and testing information. All of these files help the framework run faster by reducing repeated processing. Then there's the storage/logs directory, where Laravel records error messages, warnings, debugging details, and anything your app needs to track for troubleshooting. The most common file here is laravel.log, which becomes an essential tool when diagnosing issues in your project. Since this storage folder itself is not publicly accessible for security reasons, Laravel uses a symbolic link to safely expose only the files that the browser needs when you run the artisan command php artisan storage/link. Laravel creates a link between public/storage and storage/app/public. This allows assets like uploaded images to be served to the browser without exposing the entire storage directory. The public folder accesses only what the symlink points to, while the rest of the storage remains protected. This structure ensures that your application stays secure while still allowing users to access necessary uploaded files. Overall, the storage directory acts like the private workspace where Laravel quietly manages cached data, logs, uploads, and system files to keep your application fast, reliable, and organized.
In this part of the Laravel project structure, we explored the tests directory, which is where automated testing is organized to ensure your application works exactly as intended. Laravel supports both PHP unit and pest, giving developers flexibility in how they write and manage tests. Inside the tests folder, you'll find two primary types of tests:
Feature tests and unit tests. Feature tests simulate real user interactions by testing the full workflow of your application, everything from routes and controllers to views, models, and database interactions. For example, a feature test for an API route might send a request to API/users and then verify that the response is correct, the right controller method was used, the database was queried as expected, and the final result matches what your application should return. This level of testing gives you confidence that entire sections of your application behave properly as a whole. Unit tests, on the other hand, focus on much smaller, isolated pieces of logic. Instead of testing how multiple parts work together, unit tests check individual functions, methods, and classes in complete isolation. These tests are incredibly useful for validating calculations, utilities, or small chunks of business logic without worrying about the rest of the system. As your application grows, automated testing becomes more and more important because it helps catch errors early, prevents bugs from slipping into production, and ensures that new changes don't break existing features. With Laravel's built-in testing support, you can continuously validate your application at every level, from the smallest function to the full user experience, creating a more stable, reliable, and maintainable project.
In this part of the Laravel project structure, we look at the vendor folder, which is entirely generated and managed by Composer. This directory stores all third-party PHP packages that your application depends on, including the complete Laravel framework source code itself. Whenever you install Laravel or add new packages using Composer, everything is downloaded and organized automatically into this vendor directory. Because this folder contains core framework files and external libraries, it is not meant to be edited manually under any circumstances. Changing anything inside vendor could break your application instantly, since these files are foundational to how the framework operates. If the vendor folder ever becomes corrupted, accidentally deleted, or missing after downloading a project from someone else, you simply run the command composer install, and Composer will restore everything exactly as needed. The vendor directory acts as the engine room of your Laravel application, full of essential packages, dependencies, autoloaders, and framework components that make your project function smoothly. Laravel relies heavily on Composer to keep this environment organized, modern, and up-to-date, allowing you to focus on your application logic while Composer handles the underlying structure.
In this part of the Laravel project structure, we explore the essential root-level files that power your application behind the scenes. These files sit at the top of your project and act as the control center for dependency management, command line operations, front-end builds, and automated testing. The composer.json file is one of the most important components because it manages all PHP dependencies that your application requires, including Laravel itself and any additional packages you install. It also defines auto-loading rules, telling Laravel how to automatically load your classes without manually requiring files. Working alongside Composer, the Artisan file is Laravel's command line interface, giving you access to dozens of powerful commands. With Artisan, you can generate files, run migrations, seed data, list routes, clear caches, start the development server, and much more, all from a single command line tool. On the front-end side, the package.json file plays a similar role, but for JavaScript and Node-based dependencies. It manages everything needed for your CSS and JavaScript build process, from Webpack or Vite configurations to libraries like Vue, React, Alpine, Tailwind, and more. Through NPM or Yarn, package.json controls how your front-end assets are compiled, optimized, and delivered to the browser. Finally, the PHP unit.xml file handles configuration for the PHP unit testing environment. It defines how tests should run, which folders to scan, and how to structure both unit and feature tests. This setup ensures that your entire application can be validated through automated testing, helping catch bugs early and maintain long-term stability. Together, these root-level files form the backbone of your project's ecosystem, managing dependencies, powering commands, building front-end assets, and ensuring your application behaves exactly as expected.
In this final view of the Laravel folder structure, we get a simplified mental map designed especially for beginners, helping you understand exactly what belongs where inside a Laravel project. At the heart of everything is the app folder,
which contains your core logic, models that interact with the database, controllers that handle user requests, middleware that filters those requests, and services that power advanced functionality. Right beside it is the Resources folder, home to your blade views and front-end assets, where you build the visual part of your application. The Routes directory defines all the URL mappings for your application through files like web.php and api.php, ensuring every request knows exactly where to go. Next, the config folder and the important .n file control all application settings, such as database connections, mail drivers, and application modes, giving you full flexibility across different environments. Moving deeper into back-end concerns, the database folder manages your database structure and sample data through migrations, seeders, and factories, which help you build tables and populate them for testing or development. The storage directory holds everything generated during runtime, such as logs, caches, uploaded files, and compiled blade templates, while the public folder acts as the only web-accessible area, the front door through which all browser requests enter your application. And finally, the vendor directory stores all Composer-installed packages, including Laravel's own framework code and any third-party libraries your project depends on. To help you decide where things should go, the diagram also gives a simple rule of thumb. If you're creating a new page, you start with a route, then a controller, then a view. If you're storing data, you create a migration and a model. If you're changing settings, you update config or the .n file. And if you need to check for errors, you inspect your storage logs. This mental map ties the entire Laravel ecosystem together, giving you a clear, intuitive understanding of how all the folders work in harmony to power a modern, well-structured web application.